Hello, professionals and developers. Welcome to our EZPZ0S Spring Release 2024. I'm Harrison, your host. Thanks for all the effort for the past 2 months and our hardworking members, where I could have this chance to bring you to our greatest magic. I show in the title, we're building an next page, please. Yeah, I show in the title, we're building an OS for restaurants and markets, involving the ordering system and material management and multi-platform responsive design and with the user-friendly interface. And we have 2 professional wizard teams, and one for implementation and the other one for deployment. And 2 teams work closely, but still having their own presentation in turn. And we have a plan in general to make sure there's no surprise in every stage we break down, and also to keep it trackable, measurable, and easily adjustable. The outcomes we achieved and the difficulties we encountered could not be morally missed here. And of course, we're also going to talk about our ambition and further actions. Now I'm going to pass my microphone to Mr. Leo for our plan.
Thank you, Harrison. I'm Leo. I will introduce our project plan. Our project aims to create a user-friendly, web-based ordering platform for the restaurants, prioritizing ease of use and flexibility. The platform will feature a mobile-first, responsive UI that adapts to across various devices, ensuring a smooth user experience. By integrating QR code scanning linked to table-specific menus, we streamline the ordering process, making it more efficient. Key features like OTP-based login, personalized user profiles, and a shopping cart further enhance the user experience. The platform also supports efficient menu management, allowing restaurant management to easily add, modify, and query items. Additionally, it facilitates seamless interaction between clients and the restaurant management through real-time order updates and dish status tracking. To cater to diverse use needs, the platform includes a reservation system, voucher management, and a tax system for menu items. In the next section, Mary will introduce the current stage of our project.
Okay, thank you, Leo. I'm excited to update everyone on our project as we reach the midpoint and move into spring fall. So we've made a great progress so far. Let me walk you through what we've accomplished and where we're heading next. So where do we stand? We've successfully developed the menu page along with all its functionalities, making it easy for users to navigate and place orders with no hassles. We've also implemented OTP login and sign-up features. This ensures that users can securely create and access their accounts. On the business side, we've completed the menu management interface, which allows staff to efficiently manage and update the menu. This means customers always have the most accurate and up-to-date information at their fingertips. As we move forward, our focus will be on the booking system. This feature is crucial because it will allow users to select a date and a time for their reservations, ensuring a smooth and seamless experience from start to finish. Given our project so far, we're confident that we are on track for a successful implementation of the next step. However, no project is without its challenges. To give you more insight into the difficulties we've encountered and how we're tackling them, I am going to hand it over to Lancy and Lynn.
Thank you, Mary. I'd like to address some of the challenges we faced during the development of our EZPZ order system and how we've tackled them. One of primary difficulties was the complexity of our code base, which made understanding and maintaining the code a daunting task. Additionally, the frequent use of console.log for debugging, especially during the backend development, cluttered our development environment and hindered our progress. To overcome these issues, we developed a comprehensive logging system within the EZPZ.core framework, and this system not only replaced the scattered console.log statement, but also provided us with more insightful and organized debugging information. Furthermore, we standardized our code documentation by using @param to write clear and informative comments. This practice significantly improved our code readability and maintainability, making it easier for all team members to understand and contribute effectively. Additionally, we centralized our constant and mock data by placing them into the EZPZ.core, and this move allowed us to maintain consistency and easily manage our strings across the EZPZ.web application. By doing so, we minimized the errors and related to the hard-coded values and also made our system more adaptable and easier to update. Later on, Lin will talk more on the other difficulties that we encountered.
Okay, thank you, Nancy. Add to the point, we also faced issues with inconsistent folder and file naming, which caused complications in our Git management and also compromised our code's readability and maintainability. To address this, we implemented clear naming conventions and code standards. As you can see, we've set strict rules to avoid these discrepancies, and we've established a pull request rejection table to enforce these guidelines. This has helped maintain consistency, reduce errors, and streamline our development process. Next slide, please. In addition, our application is built on a complex and commercialized framework structure consisting of 3 repositories: the database layer library repo, the transitional layer backend repo, and the user-facing front-end repo. To enhance the readability and single responsibility of our application, we adopted a clear separation of concerns between the backend and frontend. By implementing a one-to-one mapping between controllers in the backend and services in the frontend, we ensure that each part of the application has a focused responsibility. This approach makes the code easier to understand, maintain, and extend. Next, Eric is going to talk about our future plan.
Thank you, Lin. Hello, everyone. I'm very excited to be here to talk about the future of our project. In the future, we will continue to develop some front-end pages left, back-end interfaces, and request interfaces. We also develop responsive pages suitable for PC and develop a payment function using script. And we also test the whole process of our project. Okay, that's all. Please let Amy introduce the performance of our project.
Thanks, Eric. I'm Amy, and I'm happy to share our achievements on the EzPzOS project. Over the past sprints, our team has made significant strides in developing a responsive, user-friendly ordering platform for restaurants. We have successfully implemented a range of features from menu management and user profile to complex API integrations. As seen in our performance summary, each team member was assigned specific tasks related to either the front end or back end, with tasks categorized by their status, whether not started, in progress, or reviewing. Analyzing the points earned across the sprints shows consistent progress, and each team member has contributed effectively, from back-end API development to refining the front-end interface. Looking ahead, our focus will be on finalizing the remaining features and conducting user testing to ensure a seamless experience. I want to acknowledge the hard work of the entire developer team. Your dedication has been key to our success. Together, we are on track to deliver a product that will truly enhance restaurant operations. Next, let's pass the microphone to our DevOps team. Ben will give you an introduction on DevOps work.
Thank you, Amy. Hello, everyone. I'm Ben, and I'm glad to introduce our DevOps work plan. Based on project requirement, we've planned our work into 4 stages: manual deploy to AWS, Terraform deploy to AWS, monitoring, and EKS. Now we have complete both manual deployment and the Terraform deployment. Next step, we will do monitoring and deploy EKS. In the stage 1, we have successfully deployed both front-end and back-end CI/CD pipeline and connect to the RDS database. We use the GitHub for the code and the version management, use Jenkins server for the CI/CD pipeline, and use AWS Cloud to support our project. In the stage 2, in order to improve efficiency of our work, we use Terraform to define and manage all cloud service. Our team member Leo will show how the Terraform works later. In the stage 3, we plan to use CloudWatch and Grafana to monitor all the projects. CloudWatch will monitor all AWS resources, providing detailed insight into system performance. Grafana will be used for data visualization, allow us to analyze metrics, set up alerts, and manage notification. After that, we will use EKS service to enhance performance for our project. This is our work plan. Now, welcome Chris to introduce his work, manual deploy structure.
Thanks, Ben. Hi, everyone. My name is Chris, and I would like to show you the EZPZ deployment architecture overview. Our application follows scalable structure, leveraging AWS services for both front-end and back-end operations. We start with our VPC, which spans 2 availability zones for high availability and fault tolerance. Within this VPC, we have 1 public and private subnet in each zone. On the front end, we have Jenkins managing CI/CD, where the front-end code is fetched from Git, built, and then pushed to our S3 bucket. This bucket serves the static content distributed globally through CloudFront for low latency access. Users interact with the app via Route 53, which routes the traffic efficiently. For the back end, we have Jenkins performing a similar CI/CD process, pulling codes from Git, building Docker images, and pushing them to Amazon ECR. Then ECS Fargate orchestrates these containers within private subnets, ensuring the security. We also have an application load balancer distributing traffic between Fargate tasks across availability zones to ensure high availability for the application. Monitoring is handled by CloudWatch and Grafana, while our RDS stores the app's data securely. These setups ensures a seamless and resilient deployment process from front-end to back-end. And thank you, and I'll hand over to Neo, who will talk about the Terraform structure for this deployment.
Well, hello everyone, my name is Neo, and I would like to walk you through the architecture of our Terraform-based AWS infrastructure, which supports both UAT and production environments. We start at the developer interface, where the Terraform CLI is used to create and manage AWS resources across different component directories. This modular approach allows for organized and scalable deployments. At the core is the UAT and production main module, which creates an application load balancer as the entry point for backend services, APIs, and the Jenkins dashboard. This ALB is used by various components, including the front-end module for handling front-end requests, and the ECS module where our backend services runs in an ECS cluster. These components use the network provided by the VPC module, ensuring secure communication within a private VPC. The shared ALB ring module and the shared ECR ring module are critical for managing shared resources. The ALB binds to the ALB target group module to route traffic according to the listener rules defined in the ALB listener rule module, which use HTTP host headers for traffic direction. The ECS cluster pulls container images from the ECR, ensuring that our back-end services are always running the latest version. The shared Jenkins main module is responsible for setting up Jenkins master and slave instance on EC2, which automatically installs and configures the cluster. Terraform state files for these resources are securely stored in the S3 module. Lastly, we integrate network and security layers through modulars like CloudFront for content delivery, Route 53 for DNS management, and ACM for certificate provisioning. The Route 53 record module relies on domain routing, and the ACM module provides domain validated certificates to ensure secure communication across the infrastructure. And our team leader, David, will introduce what we've done so far, what we're currently doing, and what we'll do in the future.
Thanks, Leo. So my name is David. So let me just quick talking about what we're doing so far, what we'll be doing in the futures. So currently, we have successfully built the front end and in the manual way or in the Terraform way. So in the back end, we are developed in the manual way and the Terraform way, which is the front end can be accessed into the LP that is targeted into the back end with the RDS database running at the same time. So in the next section until the next demonstrations, we will focus on the Kubernetes and the monitoring. For the Kubernetes, we aim to deploy EKS in the way of manual or Terraform AIC. For the monitoring, we will set up the privacies and the Grafana or the EC2 to the monitor Jenkins, ECS, and container. In addition, we plan to set the EKS server to read the logs from the AWS and the Jenkins. And so that is the end of the DevOps sections, also the EZPZ sections. Thanks, everyone.
Thanks, DevOps teams. Hello, I'm Kino. I'd like to take a moment to reflect on the progress we have made with the EzPzOS project. Over the past month and a half, we have seen significant advancements. And now, as we enter Sprint 4, it's clear that we are on the right track. The addition of our DevOps team members has further strengthened our capabilities, and the collaborative efforts among all team members have been instrumental in overcoming challenges along this way. Moving forward, our primary focus will shift towards back-end coding, which is crucial for our continued success. We hope everyone to maintain this momentum and dedication as we work towards completing our project. Let's keep pushing forward together.